Greetings, esteemed netizens. It is fascinating to explore the mysterious universe of Voyager 1, which currently resides at an impressive distance of over 24 billion kilometers from Earth, venturing into the vast interstellar space. What initially appeared to be a simple mission to study Jupiter and Saturn over half a century ago now unfolds as an intriguing cosmic puzzle. The messages sent by Voyager 1 in this unknown territory have sparked speculation and surprising theories. Rumors suggest that the probe may have encountered an unknown force, fueling imagination and raising questions about potential hidden information from the public. The lingering question is, what exactly is happening with Voyager 1, and are we prepared for the unfolding developments? However, the history behind these probes is equally thrilling. Originally designed to explore Jupiter and Saturn during a rare planetary alignment in 1977, the Voyager 1 and 2 missions were supposed to last only 5 years. Nevertheless, these resilient probes defied all expectations by reaching the remarkable milestone of half a century of existence. How was this possible? Enthusiastic engineers driven by a broader vision challenged the initial instructions to focus solely on observing Jupiter and Saturn. Ignoring budgetary constraints, they decided to broaden the mission's horizons by building not just one, but 2 probes as a precautionary measure. This audacity and boldness, within the budget of $250 million at the time, reveal an era when space exploration was permeated by a pioneering mindset. Thus, as Voyager 1 continues its intriguing journey through interstellar space, the narrative behind its creation and persistence over the years adds a fascinating layer to our understanding of the cosmos and space exploration. We are faced with an extraordinary legacy that transcends the initial boundaries of a planned mission, immersing us in a universe of unforeseen discoveries. What else does Voyager 1 have in store for us on its journey into the unknown? Only time will tell. The Voyager program, conceived as a bold venture by NASA into the cosmos, stands out as a monumental feat in the history of space exploration. Launched in the 1970s, the Voyager probes were meticulously designed and constructed to withstand the rigors of deep space, incorporating cutting-edge instruments and the most advanced computers of the time. This intergalactic saga was marked by innovation and vision, a true celebration of humanity's relentless quest for the unknown. One of the most fascinating aspects of the Voyager probes is the inclusion of golden records, a kind of cosmic time capsule. Coordinated by a committee led by Carl Sagan, this record contains a rich tapestry of sounds, images of Earth, and a variety of 55 languages, representing a symbolic expression of Earth's diversity and culture. The gesture, marked by the words of then-President Jimmy Carter, echoes as a gift from our planet to potential extraterrestrial beings, a cosmic message that transcends earthly boundaries. President Carter expressed at the time, "This is a present from a small distant world. We hope to survive our time so we may live into yours. We leave you a record of our science, our culture, our thoughts, and our feelings." These words resonate with the human aspiration to reach beyond our planet, seeking a cosmic connection that transcends the limitations of time and space. Originally intended to explore the giant planets Jupiter and Saturn, the Voyager probes exceeded all expectations, extending their mission to include the distant planets Uranus and Neptune. This remarkable success was made possible by a rare planetary alignment that occurs only every 175 years, providing a unique opportunity for the probes to take advantage of gravitational assistance. As the Voyager probes venture farther from our solar system, the complexity of the challenge increases. The gravitational pull of the Sun gradually slows down the probes. However, the mission's ingenuity is revealed in the use of gravitational assistance, a technique that involves harnessing the gravity of planets to propel the probes, enabling an efficient and sustainable trajectory through interstellar space. Thus, the Voyager probes, each weighing 722 kilograms and laden with fuel, have transformed into intrepid ambassadors of humanity, navigating the far reaches of space and providing an unparalleled glimpse into the cosmos. As they continue their circular journey around the planets, these fearless space explorers carry not only state-of-the-art scientific instruments, but also the collective aspiration of humanity to unravel the cosmic mysteries that await beyond the known horizon. The Voyager probes did not limit themselves to photographing the planets and analyzing their atmospheres. They pioneered detailed observations of the satellites of gas giants. By capturing tens of thousands of photographs, these space explorers gifted us with unprecedented glimpses, revealing geysers on Triton's moon, the volcanic activity of Io, surprising details of Saturn's storms, Jupiter's massive magnetic field, Uranus's axial tilt, and the powerful winds of Neptune. One of the great surprises unveiled by these space missions was the dense nitrogen atmosphere on Titan, resembling Earth's atmosphere. Additionally, the Voyager mission had the privilege of discovering 22 new moons, marking the first time we detected oceans beneath ice crusts on other celestial bodies. After reaching Neptune and capturing impressive images of its large dark spot, Voyager 2 continued its journey towards interstellar space with an uncertain destination. On the other hand, Voyager 1, since Saturn, achieved a remarkable speed of 21.4 kilometers per second, providing it with enough energy to overcome the gravitational pull of the Sun, anticipating its eventual departure from the solar system. Currently, Voyager 1 holds the title of the farthest probe, situated nearly 23 light hours away from our star. As it distanced itself from Saturn, Voyager 1 saw its speed gradually reduced, maintaining a constant pace of 17 kilometers per second. At this distance, the gravity of the Sun no longer exerts significant influence, allowing the probe to venture beyond the familiar boundaries of our solar system. Entering this unknown region, we discovered the fascinating heliosphere, a vast expanse extending for more than 100 astronomical units. This area, where the solar wind, laden with charged particles like protons, meets the interstellar medium, forms a kind of oval-shaped shield, revealing more intriguing nuances of the vast cosmos that surrounds us. The Voyager program, with its incredibly durable probes, provided a series of remarkable discoveries that elevate them to the status of some of the most successful missions in space history. These spacecraft, dating back to the 1970s, continue to astonish many, leaving us intrigued about how these relics from the past are still operational and transmitting valuable data. The key to the longevity of the Voyager probes lies in their ingenious power source, plutonium batteries, specifically radioisotope thermoelectric generators containing plutonium-238. This radioactive element emits radiation continuously, generating heat that is converted into electricity through devices called thermocouples. With an estimated lifespan of 87.7 years, these generators provide power to keep the probes functioning and transmitting data, highlighting the remarkable engineering behind this achievement. Examining the storage capacity of the probes reveals a revealing surprise. The Voyagers have 3 computers operating at a speed of 11,000 instructions per second, with a modest memory of 69 KB and magnetic tapes capable of storing up to 67 MB of data. Despite appearing modest compared to modern devices, these computers were true technological marvels in their time. While the Voyagers continuously send data to Earth to avoid saturation, their storage capabilities, although limited compared to current smartphones, were revolutionary at the time of their launch. However, like everything in life, including space exploration, there is an end. The Voyager probes, although resilient, are not exempt from the inexorability of time, consuming approximately 470 watts of energy to keep all their instruments operational. The thermoelectric generators provide progressively less energy over the years. Faced with this challenge, a pragmatic solution was adopted, entering into power-saving mode. This involves shutting down non-essential instruments, such as cameras and infrared spectrometers, preserving energy for the continuity of the mission. Currently, the Voyagers only maintain operational sensors for cosmic rays, charged particles, and plasma, adapting to the constantly declining energy demands and prolonging their legacy as tireless cosmic explorers. Before definitively concluding their mission, the Voyager probe gifted humanity with a final unique view of Earth, capturing a memorable photograph from over 6 billion kilometers away in 1990. This image, known as the pale blue dot, was requested by Carl Sagan and became an icon of space exploration, offering a unique perspective on the fragility and singularity of our planet. The luminous bands present in the photograph result from the scattering of sunlight, adding a poetic touch to the visual farewell of the probe. After transmitting this last image to Earth, the Voyager cameras were permanently deactivated, marking the end of their visual recording journey. This measure not only symbolized the closure of an era of direct observation, but also contributed to a significant reduction in the probe's energy consumption, which reached less than 20 watts, equivalent to a fraction of the consumption of some modern light bulbs. The Voyager probes, while representing a technological feat of the 1970s, continued their odyssey through interstellar space, maintaining their functional hardware amidst the cosmic vastness. However, on Earth, where technology advances rapidly, significant challenges emerged. Failures began to become more apparent in recent years, given the remarkable longevity of these spacecraft. In 2022, Voyager 1 faced an issue in its systems that impaired its orientation capability and resulted in the transmission of confusing data. Skilled engineers had to implement updates with patches to overcome the complications, thus extending the mission and allowing the antenna to continue pointing towards Earth. The degradation of systems over time has become an inescapable reality. Prolonged exposure to cosmic radiation and decades of continuous operation have left their mark on the components of the probes, affecting batteries, scientific instruments, and communication systems. Additionally, the gradual decrease in power is an inevitable consequence of the decay of plutonium, 238 isotopes used in the radioisotope thermoelectric generators, RTGs. Each year, the Voyagers lose 4 watts of power, witnessing the ongoing challenge of keeping these pioneering spacecraft operational as they traverse interstellar voids, while here on Earth, we continue to reflect on the extraordinary legacy of these space explorers. Throughout their extraordinary space journey, the Voyager probes faced technical challenges that highlight both resilience and the need for adaptation in long-duration missions. Various software errors emerged over the years, causing temporary disruptions in their operations. At crucial moments, the expertise of retired technicians who participated in the original project in 1977 was called upon to resolve complex issues, often involving references to manuals from that time. The original control and analysis software for the spacecraft was developed in Fortran 5 and later underwent updates to Fortran 77. Further evolution occurred with the transfer of parts of the software to the C language. This intricate programming system plays a vital role in the probe's operations, facilitating communication with Earth through binary codes composed of zeros and ones. These binary codes, using the representation of on for 1 and off for 0, can transmit a variety of information, from text characters to complex images. However, communications are not without challenges, primarily due to the immense distance between Earth and the Voyager probes. Transmissions can be intermittent, subject to interference, and in some cases, the waves may struggle to transmit data to Earth or receive commands. The complexity of this process is amplified by the fact that each command sent to the probes takes an impressive 22.5 hours to reach them, and then at least 46 hours are needed to verify if the command was effective. The intriguing story of the Voyager takes a new turn when controversy arises around strange data sent by Voyager 1. These events occurred during the years 2012 and 2018, respectively, when the probes seemingly passed through an energy wall, also known as the termination shock. This is a phenomenon marked by the encounter of the heliosphere with the interstellar medium, characterized by temperatures in some areas reaching almost 50,000 degrees Celsius. The extremely low density of the interstellar medium, however, prevented the Voyagers from being affected by this phenomenon, although the nature and origin of this mysterious energy wall remain a fascinating enigma. Understanding this interstellar medium not only deepens our knowledge of the nature of the stellar system and radiation behavior, but also has significant implications for future explorations. The impact of these missions goes beyond space exploration, echoing the spirit of ancient navigators who faced celestial tides in their quest to conquer the unknown. This energy barrier is unrelated to the intelligible data that Voyager 1 sends us. The problem lies in an error in one of the three main computers, specifically in the Flight Data System FDS computer, designed to collect information from scientific instruments and engineering data about the state of the spacecraft. Since the end of 2023, the probe has been transmitting repetitive sequences of zeros and ones, and so far, a solution has not been reached. Although in previous situations it was possible to restart or update through patches, this time all attempts have proven futile, even after repeated reboots and instructions sent. NASA states that the FDS is not communicating correctly with one of its subsystems called the Telemetry Modulation Unit. This implies that, for now, we do not have access to scientific data from Voyager 1. Fortunately, Voyager 2 continues to operate with its patches and updates, but all indications suggest that sooner or later it will face the same issue as its sister probe. It is essential to clarify a point that has caused confusion in various media, insinuating that Voyager 1 had discovered alien life and that this code would be the key to such a revelation. In reality, space is so vast that it is virtually impossible for the probe to encounter life of any kind. In fact, the Voyagers are like drifting vessels that have not yet left the solar system. If they were to decide to do so, it would take approximately 17,700 light-years to cross the Oort cloud. The Voyagers move at such a modest speed that, in their trajectory, the probability of encountering any habitable planet is virtually non-existent. They will remain subject to the celestial tides of the Milky Way, navigating in the same plane as the Sun. There is a possibility that they will approach within 1.6 light-years of the star Gliese, 445 in about 40,000 years, and 1.7 light-years from Ross, 248 by then. However, it is likely that nothing of humanity will persist in that distant future. Over half a century, the Voyagers have been our valiant motherships, achieving incredible feats that echo through time and space. Currently, we are embarking on a challenging journey to recover our beloved Voyager 1. Susan Dude, director of the Voyager missions, expresses hope, almost like a miracle, to rescue it. Despite dedicated efforts to reprogram and reconfigure the probe, there is a consensus that our Voyager has reached its limit. After 47 years of exemplary service, it has given everything it could, illustrating both the limited nature of our technology and the incredible capacity for achievement with modest resources. This episode not only highlights our technical present, but also urges us to reflect on the vast potential that modern technology provides us. With a wealth of technological resources at our fingertips, the question that arises is, what are we waiting for? This is a call to continue and expand our space explorations. Countless discoveries await unraveling, and this moment represents only the beginning of our grand journey. If this content resonated with you, expressing your support by liking, subscribing, and sharing would be appreciated. Additionally, consider contributing through Patreon to keep the channel active, enabling the continuation of cosmic exploration in our videos. Leave your comments, share your ideas, and cosmic hugs to all space exploration enthusiasts. The universe awaits new discoveries and extraordinary journeys.